This video I'll be talking about dimensional analysis. Sorry for the noise. So now dimensional analysis is basically when you have the dimension and you have the analysis aspect. So the dimension aspect is when you are able to compare the dimension of the real value to another. So when you have, let's say, a formula, or let's say an equation. Yes, let's use the word an equation. Now you can, when you know the real value, you can actually compare. When you know the dimensions, you can compare two of them to get that formula working. It's a very good way to get formulas working. This is like the method used to get most formulas that baffle people. That how did they even come about this? When you have the units, like when you have the dimension, you are able to compare it. So that is basically where the analysis aspect comes in. You're basically analyzing it, right? So now we have a question here. So it says the period T of a vibrating wire depends on its tension. So when you have depends, you have varies. Understand? It depends. Like now speed, like it depends on length, it depends on seconds. Now I want you to keep that idea. It depends. Now T depends on F, right? Which is the force. It depends on the length, and it also depends on the mass per unit length, which is represented by this. Now, if we look at it closely, we have alpha, we have beta, we have gamma, right? So now, when you have this, you need to introduce a constant. So T is equal to K, F, alpha, L, beta, and this Y. So we have a normal complete formula now, Abi. So now the next thing we are going to do is that we are going to make this into the dimension format. You understand? So now remember I told you that it depends. So it's not necessarily like on the same line. It can be inverse. It can depend inversely. So now let's say T, or let me use another word, A directly proportional to B raised to power, let's say C. Now for this, C can be minus 1. In short, on the long run, A is directly proportional to B, 1 over B, right? Like assuming C is minus 1. That is the basic concept. So now, when we have T is equal to, so now the next thing we are going to do is to get the dimension for everything, right? So we have T is equal to K. What's force? Force is equal to mass times acceleration, which is equal to ml T minus 2, right? So now you write this times L T minus 2. Everything, you put this alpha on it. So now next you have L, which is the length, which is like we know is L, right? So L beta times. Now this one is mass per unit length. Unit, when you have only unit, it means one. It doesn't say mass per 2 unit length. Then you're having something else. That is basically 1 over 2m over L. But that is not what you're looking for. It says mass per unit length. Unit means 1. Unit 1. So mass per unit length, that is m over L. So now you have times ml minus 1, right? So this is basically what we have now, right? So the next thing that is going to happen here is that we are going to make everything like the same family before we introduce what our T, which we all know to be time. So I'm going to equate this to this. That is basic idea. So now I have, let's say T is equal to K times M alpha times L alpha times T minus 2 alpha times L beta times M gamma times L minus gamma. I hope you understood how this came into place. So now the next thing we're going to do is to collect like times basically. So we have T is equal to K times, how many M do we have here? We have 2M, L alpha, then we have Y plus gamma times the next one is L, right? L alpha. Then what's the next one? We have B plus B. Then we have minus Y. The next one we have is times T. Luckily enough, we only have one T, so that is T minus 2 alpha. So this is basically it. Now, remember I told you T is equal to T, so now this is T is equal to K times M alpha plus times L alpha plus beta minus gamma times T minus 2 alpha. Okay, so now this is basically it, right? Now, remember T is raised to 1 power, right? Now, you can say M is raised to power 0. You understand? M raised to power 0 also means 1. So nothing is affected. Then you can also see L raised to power 0, right? So properly written, M raised to power 0 times L raised to power 0 times T raised to power 0 is equal to K times M alpha plus times L alpha plus beta minus gamma times T minus 2 alpha. So by comparison, we can easily say K is equal to 1 because there is no, you understand, there is no 1 or any, it's dimensionless. So in short, for us to extract it, we need to take something that doesn't have dimension, and we don't have anything that doesn't have dimension here, basically. You understand? Sorry for this is one. So now the next thing we are going to do now is to compare. So we have 0 here on M, right? So alpha, so we have K is equal to 1. We have alpha plus gamma is equal to 0. So you have alpha plus beta minus gamma is equal to 0 to, I am having minus 2 alpha is equal to T, which is 1. Understand? So this is basically what we have, right? So now let's firstly get the easiest one, which is alpha. So now you have from here, you have alpha is equal to 1. If you take this under this, you understand? So that is over minus 2. So that is alpha is equal to minus 1 over 2, right? So now let's put alpha is equal to minus into the next simplest one, which is this one. So that is alpha plus gamma is equal to 0, where alpha is minus 1 over 2 plus alpha equal to 0. So from here, if you make this the subject of the formula, I have 0. When this comes over, you have plus 1 over 2, which is equal to 1 over 2. So we have alpha and we have gamma. So let's introduce alpha and gamma into this one. So now we have alpha as minus 1 over 2, right? Then plus beta, which is unknown, minus our gamma, which is 1 over 2 is equal to 0. So in short, you have beta minus over 4, sorry, 2, then you have 2 is equal to 0. So beta minus 1 is equal to 0, beta is equal to 0, it is equal to 1. But we are not yet done. We are not yet done in the sense that we need to put all these, our alpha is equal to minus 1 over 2, comma, delta is equal to 1, and then our gamma is equal to 1 over 2 into the equation, which is K, which is T is equal to K F alpha delta, and then this symbol that looks like omega. So now our K is known, right? 1 times F. What's our alpha? F raised to power 1 over 2, right? Delta, sorry. Then we have L raised to power beta, right? So we have L raised to power beta. So our delta is 1. So that's L raised to power 1. Then next we have this raised to power 1 over 2. 1 over 2. So this is basically it. Now the next thing we want to do is that we want to make this more organized. Sorry for using one page. just want it to be more understand functional. So the next, that is t now is equal to from one, we need to, you can just remove this one basically. Is L raised to power minus 1 over 2 L raised to power beta, which is 1. So 1, and then we have this symbol raised to power 1 over 2. So this is basically it. Now, have you seen the usefulness? So, for something like this now, where we even know the time. So when we don't know the time, while we have force, we have L, and we have this, we can easily get T. So that's basically what dimension analysis is. So thank you for watching this video. I hope you all understood it.